This video will continue on from the configuration and setup of the PLX51PBM DP Gateway video, where we brought in the raw data of a Siemens Hydro Ranger 200 into Studio 5000. So as we've brought in the raw data now that we'd set up previously in our ProSoft configuration utility, we can have a look at the tags that we imported in with our status, our input words, 16 words and 2 words. And if we go into our instrument in our previously configured data, you can see the 16 words there and 2 words. And we can see how they relate when we were looking at the instruction manual for the Hydro Ranger 200. So just to recap, we can have a look at the words we brought in. So the status is from the PLX51 module itself, where we can have a look to see if our online data is exchanging and any device errors, etc. And our 16 words, which are the actual words coming direct from the instrument. So to create our add-on instruction, if we right-click on the add-on instruction folder and click New Add-on Instruction, I'm just going to call this inst pb HR200, and I'm just going to put in the description Siemens Hydro Ranger 200 instrument over Profibus DP network. So you can add some revision notes if you want, but I'm going to just leave this blank and click OK. Move this up here. So we're going to want to start creating our logic. So if we go down and click logic to open our window. There we go, click OK, and now we're ready to put in some of our logic to bring in all of the raw data. So I'm just going to start with a copy instruction, and I know I'm going to need 2 of these, so I'm just going to copy and paste another one of those, and I'm going to need 2 move blocks as well, so I'm just going to add another couple in here, and my move, and click move, and same again. Okay. So I'm going to want to bring in the first bit of data, which is the status from the PLX51 PBM module. So you can see I'm going to need the same data type. So you can see that on the right hand side here, PLX51 DP slave status. So I'm just going to copy that. Go back in our logic. My first parameter, I'm just going to call this PLX51 PBM underscore device input status. And then I'm going to right click on that and go new parameter. Okay, so I'm going to change my data type. That needs to be exactly the same as it is outside of the block in our raw data. So I'm just going to paste that in there. And then OK. I want to make this visible and required outside. I'm just going to give it a description. It's currently set as an input parameter, but I'm going to change this to an in-out parameter. I won't need to set the required and visible because that'll automatically be required and visible. Click OK. So now I'm going to add the local tag that will be which will used for the data inside the block. I'm going to call that PLX51 PBM underscore status. Right click new local tag. And this has to match this data type again. So go in here, I'm just going to paste that in again. Okay. And again, I'm going to give it a description. And okay that. So your destination and length, so they're exactly the same data type. So I want to just move the data coming in into our new data for inside the block. So that's just a length of 1. So that's there. Next bit, we're going to want to bring in our 16 words from the instrument. So that's an integer of 16. So check the data type and then go back to our logic. Call this PLX51PBM underscore device words. I'll put input words. Bit the same as one before. You can call these whatever you prefer, but I'm just going to try and keep it similar to what it is. So we can see we've got here integer 16, so we need that to be the same. Right click, new parameter. This is an in-out parameter again. I'm just going to put in the description. We need to change our data type to be an int and 16. Okay. Yep, happy with that. So okay on there. So now our local tag, going to call this inst underscore raw PV. So what I'm going to do is just going to take two of the words and I'm going to pull those in to be our process variable from the instrument. So I'm just going to call this instrument raw PV data. I'm going to keep it as a dint. So we have two ints coming in, word 0 and 1. So I'm just going to put from word 0, and again, the length is the destination length. So because it's a dint, it's a double integer, it'll pull in two of our integers. So our word 0 and word 1. So I'm going to put that as a length of 1. And now I'm going to want to pull in the third word. So I'm just going to drag this in here and change this, word 2. So our PV is word 0 and 1, and our status word is our word 2. So just to double check that in our manual, you can see there, our word 2 is our status word. So I'm just going to put in here underscore status. This will be our local tag again. So I'm going to right click this, new local tag, and just want this to be an integer because it's just the one word for the inst status. Then okay. So now I'm going to put an extra bit of data here. You might not want it, but I'm going to put in the Profibus node address just in case I need it for anything in the future. I'm going to have it there. But if there's anything else that you want to pull in to the block and you want to be manipulating, then you do this the exact same way as we've just done previously. So I'm just going to add in here from our local data. So we pulled the status in and I've just put in the station number. I'm going to now call this for my output tag Profibus node, and that's a single integer. So I'm just going to put this as a new parameter and put it as an output parameter. I'm going to leave it as a dint because a single integer will easily fit to a dint, and it actually is good for saving memory in Allen Bradley PLCs having dints. So I'm just going to leave that. Just going to give it a title there and click OK. So when I'm online to this, then it'll pull across whatever the instrument's node address has been set up, and I can see that in there. So we've now pulled in the data that we need. I'm just going to give this rung a title for input data. And now what we're going to want to do is manipulate our process variable, so the value that the instrument's reading. So put in a description in the run comment. Again, you can put what you like in there. I'm just going to put convert PV data to usable value. So we now need to change the order of our inst raw PV for our process variable, because we've got our two words, word 0 and word 1, going into our dint. Is a double integer, and we need to swap the words around in that double integer. So I'm just putting that into our SWPB block. So I'm just going to get my new dint tag for the destination for when the words have been swapped. I'm just going to give it a description. So we're going to want to swap around the words, but the block has a couple of options. So the order depends on the options we choose. So we've got reverse, word, or high-low. So to find out which one we are going to need, it's best to right-click on the block and you go into instruction help. And then we can see that we've got a dint here, and we've got A, B, C, D. So you've got byte, your first byte, second byte, third byte, 4 byte correspond to A, B, C, D. 2 bytes in an integer. So we've got two integers. We've got A, B is the first integer and C, D is our second integer. So basically we want to swap around A, B, C, D to be C, D, A, B, because we're moving our second word to be our first word and our first word to be our second word for the data, because we're using Profibus data coming in and we're bringing it into Allen Bradley Studio 5000. It needs converting round. So I'm just going to click word, click save on there. And I now need to basically put my dint into a real so that we get now our decimal point with our data that's in the correct order. So I'm just going to put the destination tag and call that PV for our process variable. Give it a new parameter, and that will be an output parameter so we can see the outside of the block. And again, a dint is 4 words, and there's also 4 words in a real. And so I'm going to change this to a real, and the length again will be 1 because it's the same length, but we're just changing it from a dint into a real. And now we will have readable data coming into our PV tag because we've manipulated the data to now give us the correct reading coming from the instrument. So now we're going to want to bring in our instrument status. So if we have a look from our manual for the status word, we can see that you've got 3 different statuses. You've got good, you've got bad malfunction, and bad out of service. We see hexadecimal numbers 80, 10, and 1F, which I've actually already converted into decimal, which is the 128, 16, and 31. So we can see if you get your calculator up in programmer mode, you can type in the hex number. So I'm just going to put in 80 here. If I just change that to decimal, you can see you get your 128. So it just makes things a lot easier. So again, if I want to know what 10 is, put 10, change to decimal, that's where 16 is. And again, 1F. So I'm just put 1F and change to decimal, and there's our 31, our 3 in 1. So I'm going to add in a new rung. And I'm going to give it a rung description. And I'm going to add a equals. And I'm going to want an output coil. So there's 3 of these that I'm going to need for the 3 different numbers and the 3 different statuses. And just copy and paste that. So if we have a look again here, we've got our status good, bad malfunction, and bad out of service. So I'm just going to put my coil descriptions as status underscore good, and second one status underscore bad. Last one I'm going to call status underscore bad underscore OOS for out of service. And let's just check the numbers. Check that's correct first. So good, bad malfunction, bad out of service. So I'll put those descriptions in. So I'll create these tags as output parameters for now, as I might want them outside the block. So I'm going to put the description to match. Make that visible outside the block. It's up to you what you want to have outside the block or not. Any local tags won't be shown in the data type of the block to use, but parameters will. But these can be changed depending on if you think you might want these outside the block now, and then later I might suddenly change my mind. So I'll show you that as well. I'm just going to finish putting in these descriptions. So now I'm going to want to copy my int status tag, and I'm just going to drag those down, and then my decimal values will now need to be added into this. So 128 for good, 16 and for bad, and then 31 for bad out of service. I'm just going to put those in there. So there we go. So they're all good. So now these will all light up basically as output parameters when connected to the instrument. So you'll know what the status of that instrument is. Now, first of all, though, we're going to want to know that the status of the PLX51 module is also healthy and that it's exchanging data with the instrument before looking at the instrument healthy failed. So I'm just going to add in another rung, and I'll give that a rung description. It's always good to put the rung descriptions in so that you know what that rung is doing, and if anyone else is using your program or it's for clients, they can look into this, and it basically just gives it a bit more description of what's happening, why it's happening. So it's always good to do that. So I'm going to call this device online. So I'm going to want to know that the PLX51 PBM module is online and that the device is exchanging data with it. So our instrument is talking to our PLX51 PBM module. So I'm going to call this output tag device online, and it's exchanging data. I'm going to put that in the description and OK. So I know that I need to look for 2 points from our status. And we can see here we've got an online and we've got a data exchange active. So I'm just going to copy that first one. I'm just going to drag our status here. I'm going to put in dot .4 and it automatically picks up that. So next one is data exchange active. So I'm going to do the same again. And if you can put the dot and press the arrow, you'll see all of those tags. And now our device online will show when everything's good between the PLX51 PBM module and the instrument. In this case, a Siemens Hydro Ranger 200. And now I'm going to say, as long as the device is online, I'm going to add a failed parameter output to show that when the instrument is failed, and I'll potentially have that as an alarm for outside of the block to show that it's not safe to run any plant, or if there's any control coming off this instrument, we need to know that the instrument's safe to use, and also that the device is online. So I'm just going to add in, from the status, there's a device error. So we know if there's an error with the device to the PLX51 module. And also from our status, we want to put in a bit that's the opposite basically of it being good. I'm just going to put a rung around so it's an OR condition. So if the device is device error or the instrument is saying it's not good, then it'll turn on our instrument failed condition and we'll be able to see that outside of the block. Again, I'm just going to stick in my run comment. This is the instrument healthy failed check. So I'm just going to save, and we've now got all of our data in. Status from the PLX51PBM module. We've got our process variable coming in. We've got the instrument status as well, and we have our Profibus node address. We've added in our check for device online for our PLX51PBM module to the instrument. Then we're checking that the instrument itself is not failed or is failed, and then we have the alarm. We brought in the status, so we have our outputs to check if there's any issues with the instrument. And we've also then manipulated the data so that we'll have a real value that matches what the instrument is reading. So we're now going to want to use our add-on instruction, so we can add it into our instruments routine that was previously created. So I'm just firstly going to edit my rung comment and just call the first rung be basically our description of what this routine is for. An NOP, so that means it'll just get ignored, that rung. Add a new rung, and then I'm going to drag our add-on instruction to the rung. So you can see there we've got our output parameters on the right with the status, with our device online and instrument failed. But first I'm going to call my block the same as what the instrument's called, so LIT001. So the block will be called this, and the data type will come off this tag. So I'm just checking that it's controller scope because I want to use it on the HMI or SCADA screens. That's fine, so I'm going to put the description in and click create. So now I'm going to want to put in my device input status, which is from the PLX51 module. So I'm just going to copy that. And I can paste that directly in now. And the next bit it wants is our device input words, so that's our 16 words. I'm going to ignore the 2 words for now for the totalizer. And then I'm going to paste that in. And that's all healthy now and ready to be used, and then click save. So you might want to change the order of your output parameters, or you might want to make some invisible and not have them there. So that's not a problem. Do that. So I don't want the bad out of service status, for example. So if you just go into the logic, there's a couple of different ways to do this, but this is one of the ways. If you edit the tag, basically put if it's visible or not visible. Obviously the bad, I had left that one as not visible, hence why that wasn't there. I'm going to remove the bad out of service and click apply and OK. So if I close that now, and we can see it's disappeared from there. So I want to see if the status is good of the instrument, device is online, and the instrument is not failed. So I'm going to keep those there, but I want to change the order. So I'm just going to right click on my add-on instruction, go properties, and go to the parameters. And we can see that, for example, I don't want status good at the top. So also here is where you can change the visibility as well. But what I'm going to do is just click onto the status good, and you just click move down. I'm going to put it underneath the other ones. Click apply, OK, and you can see that that's changed the order. So again, it's up to you how you want that ordered, and what you want to be visible and what you don't. So now if we monitor our tags, we can see our data type here. So we've got .pv, which is ready to be used throughout the PLC, or you might want to display it on a HMI, etc. We've got our status bad and status out of service, for example. You might not want that. You might just want the status good. visible to be used. So, for example, if I want to remove those now from those tags, I would make those a local tag and change it from being an output parameter. Just go on the drop down, click local tag. Okay, I'm going to do the same for bad out of service. Change output parameter to local tag, and okay. So I'm just going to save that. Close this. And again, if we just right click there, I'm going to go to monitor, and you can see now those aren't in there. So if you're ever searching for them in a HMI, for example, you won't have those come up, and you might just want your specific ones. Same with if you start typing your tag in your PLC, press your dot, you might not want to see those as an option. So these are the ones that will pop up that you can use. So now you've got an add-on instruction that's all set up, and you can use that now for any of your process code. Thanks for watching, and subscribe for more Studio 5000 tutorials.